In this video, I'm going to go over an example for the homework. So I'm going to use my data and go through the steps of a hypothesis test, then calculate Cohen's d and a confidence interval. And you're going to do a similar thing, but with your data. And I've written a lot of the answers out already just to save time, but some of it I haven't, so I can show you how to use the equation editor. And also in this video, I will show you how to do this Excel part so you can get your numbers. So first I'm going to do the hypothesis test. So you need to first write what variable you're going to be working with. So my scale variable is satisfaction with psych classes on a scale from 1 to 10, 10 being that they're highly satisfied. And you want to make sure that you get a scale variable and not a categorical variable, because you're taking the average of it. So just make sure it makes sense to take an average of your variable. And then you want to write your null and then your alternative. So I have the null written here already. And I chose it to be equal to 5. So we have our null hypothesis, and then mu, you're going to have mu equals, and then you're going to have some number. So this number might be different for you. And I chose 5 because 5 is right in the middle of 1 through 10. And so if you're at 5, that means you're neither happy or unhappy. So it's like right in the middle. So it's kind of like a good middle point for this variable. But for you, it might be something different. So say you had sleep. You had the hours of sleep each night, and you want to see if people have a significantly different average of sleep in college than what is recommended. So maybe you want to see if people get less sleep than 8 hours a night. So 8 would go here for that problem. So you just want to really think about what's a good kind of number that you want to compare your average to. And then you want to explain it in number 1. If you really can't think of something, you can put 0. But you should be able to think of something. So that's my null. So you're going to have it equal to some number. So mu equals some number. And then you want to do your alternative. And I would like you to use the equation editor. If you really can't figure it out, then you don't have to, but you do have to type your answers. No handwritten assignments, because it just always turns out I can't read it, or people put a bunch of pictures and don't paste it into Word, and it's just a mess. And you know, one person does it, it's not that bad, but when you have a bunch of people do it, it takes a really long time to grade. So I want you to type everything and put it in one document. So I'm using the equation editor. So you can go to insert equation here. Just click here. Or a shortcut is to press Alt equals. And now I'm going to type my research hypothesis. So H, and then I'm going to do _1. You can also go here and click this subscript if you want, if you don't want to do the shorthand. And then mu, oops. To get mu, you can do this. So \mu, or you can do insert symbol here and find it there. Alright, then you need to choose if you're going to do greater than, less than, or not equal to. So I am going to choose greater than, because I think that my class, or not my class, but people at U of H will be happy with their psychology classes. That's my prediction. So here you need to put your prediction for your research hypothesis. So whatever you think the average will be. So if you think the average is going to be greater than your number in your null or less than your number in your null, or you can't decide, it could go either way, so then you put not equal to. So I'm going to put greater than. If you want to put not equal, I think it's NE. Yeah. So you can't do that. You can also still do the symbol thing. I think it's still there. But I'm going to say that the real mu is greater than 5. Remember, your hypothesis should be about the population and not about the sample. We are using your sample to make an inference about the population. So your hypotheses are about the population. So I chose greater than because I think most students are happy with their psychology courses overall. Not everyone's going to be happy, but overall, they're happy. So overall, I think the average will be greater than 5. Again, you should justify this, and it could be different for you. Then you want to set your alpha level. And so you can do this, backslash alpha. And you can just put it at 0.05. If you want, you can change it, but 0.05 is just the standard in psychology. So most people use 0.05. Then you want to go to your assumptions. Your assumptions will not be met 100%. None of yours will. Okay, but we're going to do the problem anyways. And you just want to hope that you're not too far off on your assumptions. So random sampling, you're really going to have random sampling. So random sampling means you have your whole population and you randomly select people, and then all those people take your survey and you get data from them. But that's not going to happen. Usually your population that you're interested in is really large, and then you randomly kind of select people from there, sort of, or you might not even randomly select them, just whoever is convenient. And you just ask them. So say my population is students at U of H, and I stand by the library and ask people there. It's not really random because I'm not randomly selecting them like out of a hat of all the people at U of H. Only getting people who go by the library at that specific time. Now, how I did it, it's not too unbiased. I mean, it's not like I went to Psychi, the honors society for psychology, and asked how much people like their psych classes, because probably if they're in Psychi, they really like psychology classes because it's an honor society for psychology. So, just kind of think of things like that. Or if you were trying to get the average age of everyone in the United States is your population of interest, but you only survey college students, your average is probably going to be lower than people in total in the US. So just try to get a representative sample that's unbiased. So for me, I'm going to say it is okay. For here, it's not random, 100% random, but I don't see any real bias because I went to the library and you're probably going to get a little bit of variety of people. I didn't go to Psychi or something like that to get my sample. Okay, then you want to know if your sampling distribution is normally distributed. And one of two things need to happen for that to be true. So you only need one of these, not both, but you could have both. So I have to ask, is the population distribution normal? I don't know. I have no idea what the population distribution is. Also, let me backtrack for a second. Remember, the sampling distribution is the distribution of sample means, not of the individual people in your population. That's what a population distribution is. These assumptions are coming from the central limit theorem. So if you understand the central limit theorem, then you'll understand where these assumptions are coming from. And another way you can kind of ensure that you have a normal sampling distribution is to have a sample size of at least 30. In my case, I only have 10 people, so this isn't even true. Hopefully, for some of you, you have at least 30 people. But if you don't, it's okay. I'm not going to take off for that, but just make sure you note it that you have probably too small of a sample size. So because both of these things I'm unsure of, well, this is a no, and I'm unsure of this one, then my normal sampling distribution is probably actually unknown. That's probably more accurate because the population distribution could be normal. I just don't know it. So we don't know if we have a normal sampling distribution, but we're going to go ahead and do this problem. Now, because my assumptions aren't all the way met, it means that my p-value might be off. And so, depending on how biased your sample is and how much of the normality assumption you're violating, depending on those two things, will make your p-value less or more off. So your p-value is never going to be really perfect, but hopefully it's not too far off. The biggest thing here, if you're really going to do this in real life, is to have an unbiased sample, a reasonably unbiased sample. It's not going to be a random sample, and to have a sample size of at least 30. If you have those two things, then it's probably good. And always describe who your population of interest is, and also how you got your sample. So maybe you will say unbiased sample of UH. I surveyed people by the library. Okay, and if it's biased, that's okay, but just say why it's biased or why it potentially could be biased. No study is ever perfect, but you need to know your limitations of your study. That's important. Alright, so then step 4, you want to calculate the p-value. And what you want to do is get this information, and I'm going to go now to Excel to get this. And here's my data that I want to work with. This is my scale variable I want to work with. So I'm going to go data, and analyze, and then descriptive statistics, press OK. Pick your scale variable. You only need one. And then labels in first row because we have a name for the column. I'm going to leave it in a new worksheet here. And then have summary statistics checked and confidence level for mean checked because we'll need that later. And you can keep it at 95% because that's what I asked for in the homework. But if you want to change your confidence level, you would do it here. And then press OK. Then it'll make a new sheet for you. You probably want to move this out so you can see what it says. And now we're going to calculate the t statistic. So remember, your t is the sample mean minus your mean from the null, that number from the null, divided by the standard error. So first we're going to find the mean difference. So I'm just going to put equals here, and then your sample mean, and then minus whatever you put in your null. So for this example, I put 5, but this might be different for you. Then you just press enter. So I had a mean difference of 1.5, so that's the top of the t statistic. And then I'm going to calculate the t, so I'm going to do the mean difference divided by, and look, Excel calculated standard error for you. You don't have to use the standard deviation or the variance to calculate it, and those with the n down here to calculate it, you can just use the standard error that it calculated for you, but you can calculate it with a standard deviation if you want to. So here's our t. Alright, so let's go back here for a second. And I want you to write out your answer. So let me put this over here. And this over here. So t equals, and what you can do is you can either go here and do this fraction thing, or what I like to do is just put the top in parentheses. So I want you to show your work how you get this t statistic. So 6.3 minus 5, and then close the parentheses, divided by 0.7. And that equals the 1.857143. Alright, and then you see next, we're going to find the percentile. And then because we have a greater than problem, we're going to do 1 minus the percentile to get our p-value. So we're going to do that in Excel. You can do it in a calculator if you know how, but I haven't taught you how. I'm just going to do it in Excel. So t dot this, and then you're going to open the parentheses, click on your t-value, then comma, and then you need a degrees of freedom. So your count is your sample size, and then you do your sample size minus 1 to get the degrees of freedom. So 10 minus 1 is 9. Then you're going to put true. True gives you the percentile. If you put false, then it just gives you the individual values. So for this class, you will always put true. Cumulative probability means percentile. It's a different word for it. So here's our percentile. So if you had a less than hypothesis here for your research, so if over here in the Word document you had a mu less than 5, then this would be your answer for your p-value, but we didn't. We had a greater than. So we're going to do 1, so equals 1 minus this, and that would be our p-value. So this is our answer for this problem. But let's just say for a second, what if you had a not equal to, so you have a non-equal problem, say you can't decide which way. Then what you want to do is you're going to do equals t dot dist, and then you want to put the negative version of your t-value. So if this was already negative, then leave it negative, but it's positive here, so we want to make it negative, and then put your degrees of freedom, and then true. And voila. So look here, we got what we got for the greater than, and that's because it's symmetric. So this is another way to get a greater than p-value if your t is positive. But you don't have to worry about that, but it comes out to be the same because the t distribution is symmetric. And so if you got a non-equal to, then you're going to take this, whatever you get for the negative t, and times it by 2. And so this would be our p-value if we hypothesize a two-tailed test. So here we had a greater than, and we have an alpha of 0.05. We would say it's statistically significant, but if we couldn't decide which way to go and we had a two-tailed test, then it wouldn't be significant because our p-value is 0.09, and that's greater than 0.05. So you can see the one-tailed test is more powerful, but don't abuse it. Don't do a two-tailed test and see it's not significant and then go back and do a one-tailed test. That's unethical. So here I wrote out the p-value is 1 minus the percentile that we got. So you don't have to do all 3 different ways. Well, you have to do the percentile no matter what you're doing, but you don't have to do all greater than and not equal to. You just do the one that you hypothesized in number 1. And then what you want to do, let me close out of all this. Then what you want to do is, after you get the p-value, we're going to write a statement here. And so if your p-value is less than your alpha, then you reject the null and you say there is statistically significant evidence. If your p-value is greater than your alpha, then you fail to reject the null and you'll say there is not. Okay? But that would be the only thing that's going to change in our sentence depending on the p-value. So we're going to say at the 5% significance level, because we chose the alpha 0.5, there is, because we rejected the null, again, you say is not if you fail to reject, statistically significant evidence to conclude that the average, you want to say the average, because we're talking about the average, not an individual, and then satisfaction with psychology classes. So this is a description of your scale variable. And then you want to talk about your research hypothesis. So I said greater than, so is greater than 5. And so here's our sentence. At the 5% significance level, there is statistically significant evidence to conclude that the average satisfaction with psychology classes is greater than 5. Alright, so that's your answer. If you have a not equal to hypothesis, you might want to say you might want to specify which way it is. Alright, let's move on to Cohen's D. So here we have, you can do this in Excel if you want to. So if you want to find D, so you do equals, and then your mean difference, which we already have, divided by the standard deviation, not the standard error. Okay, standard deviation, remember, that's how you do it for Cohen's D. And we get a 0.58, and that's kind of a medium effect size. Remember, for Cohen's D, it's not dependent on the sample size. So that's why we use a standard deviation and not the standard error here. So go to that little chart that I have and find what size your effect size is. Mine was a medium. Alright, now we want to get the confidence interval. So let's do that. So this is a lower bound and then upper bound for your confidence interval. And Excel kind of gives you most of the work. So what you're going to do is to equals this, your mean, your sample mean, minus this confidence level. So this is the margin of error here. Mine is 1.58. That's the margin of error. So it doesn't give you the lower and upper bound, but it gives you the margin of error. So you press enter. And then you go equals 6.3 plus this to get the upper bound. So there's our confidence interval. And so at the 95% confidence level, I estimate the population average of psychology satisfaction to be between 4.7 and 7.89. Now you might ask, oh, well, we had a significant hypothesis test at the 0.05 level, but our confidence interval includes 5, which was from our null. Well, the difference is the confidence interval is kind of two-tailed, but we had a one-tailed test. So if you had a two-tailed test, then these would be kind of comparable, but we don't. So if you don't know what I'm talking about, look at the document that says the significance testing of confidence intervals. So if you had a two-tailed test, then it would not be significant because the 5 is in this interval, and that's what I'm looking for. But we had a one-tailed test, so we had a little bit more power. So confidence intervals can help you determine significance as well.